Hello everyone. In this video, I'm going to use Python to show you a concept about using and manipulating variables that is called different things, but primarily it's called implicit versus explicit casting and declaration. Basically, what that means is, I'll show you what it means, but what it means is how you handle in your code variables and data types. So let me start out with a simple example, and I'll get into a little bit more detail about that. What I'm going to do is I'm going to write a simple Python program that's going to concatenate two strings here. But let me start out with something really simple. Let me start out with, on line 2, I'm going to put A. This is Bob. Let me execute that. Looks like I'm missing something there. Let me go on line 3 and fix that. Let me put a paren around A, just like so, and then run the program. Now, when I run the program, it says, hello, this is Bob. Okay, not earth-shattering. I'm not going for the Programmer of the Year award with this program, but I'm just illustrating some points. So I declared a variable called A. Notice I didn't say what is the type of A. I didn't say if it was a string, a float, an int, a double, a whatever. So then on line 3, I'm printing it, and on line 4, I'm going to show you how you can see what the data type is. So if I execute this program again, I get something along the lines of, hello, this is Bob, and I'm going to get the data type of this case of A. So look, it says, well, hello, this is Bob, and it says it's a string. Now notice, I never said it was a string. In line 2, line 3, and line 4, I just said A. A equals this is Bob. Python decided to make this a string. This is called implicit casting. Notice how this doesn't work like this in Java or like in C# if you're familiar with that, where you actually have to explicitly say what the type is. So it's just a different way that programs use variables, and it's got its advantages and disadvantages, which you're going to find out in your travels. I'm just showing you the what, and then you're going to, through your travels or programmings, you're going to kind of decide the consequences on what the drawbacks are and what the benefits are. But to continue with this, I am going to write another line of code. I declare a variable B, and I says equals, how are you today? And then in C, on line 4, I'll say C equals A plus B. And on line 5, I'll change it accordingly to print C. And on line 6, just the type of C. Oh, it looks like I'm missing a quote there on line 3. I got to go in there and fix that. But anyway, let me run this now and just make sure. Let's see. There we go. Yep, unterminated literal. You should be familiar with that error. Let me go in there and fix that and go to line 3 and change that to how are you doing today. While I'm doing that, I'm going to just kind of code and kind of talk as I'm going. Notice we have C equals A plus B. It's not doing math on numbers, right? Well, why isn't it? Because Python is looking at A on line 2 and B on line 3 and saying they're strings. So if you look at the output there, it says, hello, this is Bob. How are you doing today? That is exactly what line 4 is doing. So line 4 is taking A plus B and it's equal to C. But you might notice something here. You might say, well, okay, I got two strings here, A and B. C equals A plus B, right? What if I wanted to use numbers? Well, you could in Python without explicitly saying, without putting in exactly what the types are. So what I'm going to do here is I'm going to change A. So rather than to say, hello, this is Bob, I'm going to give it an integer value, which is 10. Now B, I'm going to give B another integer value, which is 5, or anything you want. So line 4, now we have more of an algebraic expression, C equals A plus B. And line 5 is going to print what C is, and line 6 is going to print what the type is. Now notice I didn't do anything different except change line 1 and 2, or pardon me, 2 and 3. I didn't say what my data types are. That's because Python is implicitly cast. It says, oh, okay, we will make A into an integer, and we will make B into an integer without you telling us to do so. That's how Python works. Now, as I mentioned, Java does not work that way. You have to say what the types are. Same thing with C#, C++. You're going to get that as you go through languages, and this is one of the concepts you're going to have to deal with, is implicit versus explicit. Let's change line 2, and I'll change A equals 10.05, and I will execute the program, and notice I get the value 15.05, and the class is a float. Now, this is what Python did. It made A into a float, and it made B into an integer, but it tried to add on line 5. It tried to add a float and an integer, right? Because A is a float and B is an integer, because that's what Python said it was. So what Python did is it said, well, we have to make C a float too, because we got to have the right amount or the same types on each side of the equal sign. So that's what Python did. So I'm just going to put a couple comments in here. Notice in Python, we don't put the type of the variable. Now remember in PL, well, if you do know PL SQL, you have to say if it's a number, a varchar, or what have you. And if you're used to Java, you got to do the same thing. You got to say this is a string or this is a float. You can't let Java, and Java indeed will not let you get away with that. Java in English is saying, if you're going to use a variable, you need to tell me what the data type must be. Python says, if you want to use a variable, you don't have to tell me what the data type is. That leads to a lot of convenience where you could let Python do a lot of this casting behind the scenes. It also has some disadvantages. I said I wouldn't mention them, but I'll just mention a couple. A disadvantage is sometimes you don't know exactly what types you're dealing with because you're just not seeing what the types are. I mean, look at this, line 5 through 9. There's nothing in my code that says what types these things are. That could certainly be interpreted as a disadvantage. So anyway, so let me change line 6, just for example, to 5.90. I'll run the program, and I should get, eventually, I should get my answer. Now notice you got that a little bit of a rounding error there. That's to be expected, believe it or not. That 0, 1, all the way down there. That's just, that happens with when you're dealing with floats, doubles, and things like that. A subject for a different video. But you're getting the answer or the print on line 8 for 15.95, and then the type is float. So let me change this again, and let me put on line 5 and line 6 double quotes around 10.05 and 5.9. Now those are strings, right? But if I execute this program, Python is still going to say, well, actually it's going to say that they're strings, but look at my answer. It's not adding them, right? Or not adding them like numbers. It's concatenating them like strings. This is not an error. This is what you're asking Python to do. So remember, one of the pitfalls is remember when you're dealing with numbers, know what type of numbers you're dealing with, and know when you're dealing with strings, and when you need to go from one to the other. Now, you might look at this and say, well, this is kind of obvious, but believe it or not, a lot of you have this problem doing your assignments where you're like adding A and B together, but they're strings. And then you're like, it's not giving me a number. And my answer is because you're not saying it's a number. So here what I can do is, if I wanted to say explicitly that line 5 and line 6 are floats, I could do something like this. So let me make that change to line 5 and line 6. And notice I'm explicitly saying on line 5 and line 6 that 10.05 Python make it a float. And on line 6, 5.9 Python make that a float. And it does. We don't get an error. And it's saying, okay, they're not strings anymore. They're really floats. So line 7, C becomes a float because Python makes it one implicitly. And it adds A and B as if they are floats, which is what we intended in this code example. And then you see the type on line 9. It's printing the type out. So anyway, so I got the type there, type class equals float. So anyway, I'm kind of wrapping it up here. You kind of get the point. One thing I want to talk about with implicit versus explicit, this is something that's going to come up a lot. It's something that you're not going to deal with the 12 minutes of this video and say, oh, I know everything that has to do with it. It's a concept that's talked about quite a bit in programming and software engineering circles. So be prepared for that, where you'll say, hey, in this language, are you implicitly or explicitly typing? Some code examples or some code reviews might say that they as a standard for your organization, as a coding standard, that you don't allow implicit typing. You explicitly have to say what it is. So it's more than just nuance. It's more than just, hey, look at this, it works a little bit differently. It does have, eventually you'll get to see some design and implementation and code review, scalability and maintenance issues. Like, for example, if we just use implicit casting for everything, and this line of this program was 1,000,000 lines long, and 10 years later someone had to maintain it, it might not be really obvious what data types I'm using. So there's going to be all sorts of those things. Anyway, so this is implicit versus explicit. I'm going to do one more thing with this and show you that still sometimes, even with implicit casting and trying to make it explicit, you're still going to have kind of a problem. Like, for example, let's just say in line 9, I said, you know what, make 5.90 an int. Now, this should not work because Python is saying invalid literal for int. It's saying I can't make this into an integer. Remember, integers are whole numbers, and we're saying make 5.90 into an int. Python says no, can do. Can't do that at all. So what it does, it gives me the error. You're going to have to get used to this, really, seriously. So just when you think that this was easy, it's going to get more complex when you go with declaring variables and working with data types. Anyway, that's all I had for you for this lesson. Python is a cool language. It also does a lot of things behind the scenes that might get you in trouble. Know what you're getting into, and know that typecasting is something you're going to have to deal with forever. Thank you, and have a great day.